just like number one, we have a picture, okay? So the first thing to do is, what is the picture of? What does it represent? Are there things on there that could help us later down the road? Okay. So the function f is defined and differentiable. So f, the original, means there's no places from 0 to 8 where it's not going to exist. F always exists. And f is always differentiable. It's always going to have a derivative. Okay. On the closed interval from 0 to 8. The graph of f prime, the derivative of f, is shown. So same type of problem. This is a graph of f prime. Okay. It has horizontal tangents at 2, 4.75, and 6. So that means when x equals 2, it's got a horizontal tangent line there, there, and there. Okay, that's what that means. All right. Okay, so before we get to letter A, what does this represent? So this is a graph of f prime. What does that mean? It's a graph of what? Derivatives of f. So what are derivatives? What's another word for derivatives? Slopes, right? This is a graph of all of the slopes of the original. So for example, at that blue dot right there, on the original, when x equals 2, the slope is -2. Is that increasing? Is that going to be increasing or decreasing? If something has a slope of -2, is it going uphill or is it going downhill? Decreasing, downhill, right? Okay. Let's see here. Let's look at another point. Right here. 7, 1. When x equals 7 on the original, it has a slope of +1. Means it's increasing, right? It's increasing. Okay, so that's kind of the idea. Okay, so now let's use our cheat sheet from the last time, from the one we did with number 1, and answer these. Okay. So if we're trying to find the critical points for the original, where do we look? Use your cheat sheet. What does your cheat sheet say? If we're trying to find the critical points, passes or touches the x-axis, right? Anytime it passes or touches the x-axis. So definitely right here, definitely right here, definitely right there, right? Those are the 3 spots where we have critical points. Okay. So we're going to say x equals 1, x equals 4, x equals 6. That's the answer, right? That's half of the question, the answer. But then we also have justification. Because, and this is where that justification is going to come helpful. So because f prime changes signs. F prime changes signs. Okay. Done. A lot easier the second time than we did it the first time. The first time we were kind of really thinking into it, and it was not difficult, but it took some thinking, took some thought process, right? Okay. Okay, so letter B. Where is the function increasing and decreasing? So where do we look for increasing and decreasing? So look at your cheat sheet. How do we know when looking at the derivative graph, when is it going to be increasing and when is it going to be decreasing? So anywhere above the x-axis is going to be where the original increases. Because these are all answers about the original. They're not asking me questions about this graph. They're asking me questions about about the original. Okay? Decreasing. Where is it decreasing? When what is what? Below, the opposite, below the x-axis, right? So on mine, green is going to be increasing. Pink is going to be decreasing. Okay, so let's write this down. Let's do increasing first. Increasing. So we got from 0 to 1, 4 to 6, and then 6 to 8. Because at 6, it's not, 6 is at 0, right? 0 is not a positive or a negative. 0 is just 0. So that's why I broke up. It kind of looks like it goes from 4 to 8, right? But at 6, it's touching the x-axis. So actually at 6, it's actually 0. 0 is not a positive number. We only want to know where is it positive. Okay, so that's why I broke up 4 to 6 and 6 to 8. Okay, so let's go to our justifications. Where is it? Increasing, decreasing. Increasing, because f prime of x is greater than 0. Okay, decreasing. There's only one interval where it's decreasing, from 1 to 4. Because justifications, f prime of x is negative. It's less than 0. What I mean is less than 0, it's under the x-axis. Above, equal, greater than 0 means above the x-axis. Okay. Okay. Maximum minimums. Maximum minimums. All right, so let's look at maximum minimums. Let's go to our cheat sheet. What does our cheat sheet say about maximum or minimums? Where do we find those? Where do we find, let's start with the maximums. Where do we find the maximums? How do we know there's a maximum? Exactly. When the graph crosses the x-axis from positives to negatives. Okay. So we know 3 points it's going to touch. We want to know where it crosses from positive to negative. Okay. So green to pink here, it looks like positive 1. Positive 1 is a relative maximum. Then it crosses in the opposite direction, right? So that looks like 4 is a minimum. What about 6? Is 6 going to be a maximum or minimum or neither? Neither. Yeah, 6 is going to be neither because it doesn't cross. It touches, but it doesn't cross. Okay. Okay, so let's write this down. Relative max at x equals 1. Relative minimum at x equals 4. Because So if it's a max, it's because f prime changes signs from positive to negative. If it's a min, it's because f prime changes from negative to positive. Whatever you're dealing with. So if it changes from positive to negative, it's a maximum. If it changes from negative to positive, it's a minimum. Okay. Okay. Next page. Point of inflection. Where on this guy is going to be in a point of inflection? We'll go to your cheat sheets. What do we know about points of inflection? Where what? What does our cheat sheet say? So when the slope changes signs. So now we're looking at the slope, not the y values. We're looking at the slope of this guy. So when the slope of this guy changes, that's where we're going to have points of inflection. So now we're looking at the slopes. Okay. Starting off, am I increasing or decreasing here? Decreasing, right? We're not looking at it in terms of, we're looking at the slopes of this. So I'm decreasing here. Whenever I change direction, that's going to be a point of inflection. So it looks like a change direction there. Change direction there. And change direction there. So where are the points when I'm changing direction? There's 3 of them. 2, positive 2, right? Change from decreasing to increasing. Where else? Yeah, 4.75. 4.75 right about there. How do I know it's 4.75? Because it told me in the beginning. And 6. Those are the horizontal tangents that they told me about. So all 3 of those are going to be points of inflection. Okay. Let's write this down. Points of inflection at x equals 2, x equals 4.75, x equals 6. Because okay. What's true about all of those points on the graph? All of those points on the graph are where we have what? What do the directions say? All 3 of those are where we had. What do the directions say? Go back to the directions. What do the directions say about those 3 dots? Why were those 3 dots important to tell us? But what did it say? What did it say in the beginning and the top? Horizontal tangents. Yeah, horizontal tangents. So what do horizontal tangents mean? Slope of 0. Slope of 0. So there's our justification right there. Because f double prime changes signs, like you guys said, which is the same thing as saying f double prime equals 0. Either one's okay. Either one's okay. Changes direction, changes signs, equal to 0. Either of those is okay. All right. Concave up, concave down. Concave up, concave down. Okay. So let's write concave up, concave down. Okay, so what did our cheat sheet say to look on the graph? Where do we look on our graph for concavity? There you go. When the slope is positive or when it's increasing or decreasing. Okay, so this guy we said was decreasing, right? Negative slope. Second derivative is going to be negative. Okay. Then it becomes positive. Then it goes back to negative. And then it ends positive, increasing, right? So we said when the slope of this graph is positive, in other words, increasing, concave up. When the slope of this graph is negative, in other words, decreasing, concave down. Okay? So it looks like the yellows are concave down and the blues are concave up. So concave down, it looks like from 0 to 2 and 4.75 to 6. Okay. The blues are increasing, positive slope. 2 to 4.75 and 6 to 8. Okay. All right, so those are our answers. Now we need justifications. Because so we knew the yellow was concave down because the slope f double prime was negative. We knew the blue was concave up because f double prime is positive, right? The slope. Those are going to be our justifications here. Concave up because f double prime is positive, increasing. Concave down because f double prime is negative, decreasing. Okay. Because f double prime is greater than 0 because f double prime is less than 0. Okay. Along with this, they're always going to give you a new function, g of x. So the last thing they're always going to do on a free response, they'll ask you questions about increasing, decreasing, relative maximum, relative minimum. Where is the concave up, concave down, points of inflection? They'll always throw in a new guy, g of x. We don't have a graph for g of x. I don't have a graph, right? But part of f so it's taking something else and subtracting f of x. That's g of x. And they want us to find g prime of 2. So if this is what I need to find, if that's the guy I need to find, what's the first thing I need to do? Find the derivative of g. Okay. So g prime of x equals, well, I got a minus sign in between them. There's a minus sign in between them. So I don't have to use product rule. I don't have to use quotient rule. I don't have to use those things. If that green thing was a multiplication, then you would use product rule. But it's not. It's a subtraction. So that means I just find the derivative of x squared. The derivative of x squared is just 2x. What's the derivative of f of x? F prime of x. Yep. That's the derivative. Plug in 2. Everywhere you see an x, I'm going to plug in 2. Okay, 2 times 2 is 4. Minus. How do I find f prime of 2? There you go, right? I'm going to use the graph. That guy right there is the y value when x equals 2. I have a graph of f of x, of f prime, sorry. I have the graph of f prime. So what is the y value when x equals 2? Negative 2, right? Yeah. That blue dot right here that I made earlier. Negative 2. G prime of 2 equals positive 6. Done. Okay. So let's say they gave us something like this. Let's say the question was something like this. Let g of x equal x squared times f of x. Find g of 2. Let's look at this question. This one's a little bit different because instead of subtraction, it's multiplication. So when I found g of x, what would I need to use? Product rule. So we'd say the first times the derivative of the second plus the derivative of the first times the second. This one we're not going to be able to do because you need integration to do this. But this is because then if I plug in, watch. So I get 4 times this, and then 4 times this. Well, f prime of 2 we've just figured out, right? It was negative 2. But this guy here, we're not going to be able to do as of yet. This guy we can't do yet because to go from a derivative to an original, we would need integration. We'll do this next semester. Next semester, this is what we're doing. How do I find the original when I have a derivative? You integrate. But we're not there yet. So we can't finish this one, but you get the idea, right? The main reason was this is what I was doing it for. right? The difference between when, because that's what I'm seeing a lot of when do I use product rule? When do I not use product rule? Quotient rule, you guys are pretty good at because quotient rule is kind of obvious. You know, when there's division, you use quotient rule. But it's just kind of more like, when do I use this? When do I not use that? Right? This question here, I think there was on a quiz or something on a test, something like this, right? Like x. This was f of x. And the question was find the derivative. A lot of you were confused. How do I do this? Well, it's just, that's one guy, that's the other guy. Are they being added or subtracted or multiplied or divided towards each other? Multiplied, right? Then I use product rule, right? Find the first times the derivative of the second. Now to find the derivative of the second, I'm going to have to use the chain rule, right? That type of thing. Okay, that's one of the biggest things. When do I use this rule? When do I use this rule? Rules are used for specific reasons. We can't always use the product rule. I can't always use the chain rule. I can only use them when I need. Okay. Okay, so let's see. Write down the justifications. I'll let you guys write down the justifications. And then I'm going to give you some, last thing we're going to do is, I'm not going to give you the assignment yet. I'll give you the assignment tomorrow. What I want to do is I'm going to give you different graphs. And I'm going to ask you questions about it. Where's this? Where's this? Where's this part? Where's that part? Okay, but write down the justifications first so that you have them. They're on Google Classroom, but since we have some time,